Hello and welcome to Vodcast 16.6. In this podcast, I will overview galaxies and galactic clusters. By definition, galaxies are collections of interstellar matter, stars, and stellar remnants that are gravitationally bound. Our Sun is one star in a galaxy, and our galaxy contains more than 100 billion stars. And if there are hundreds of billions of galaxies out there, each of which contain hundreds of billions of stars, there are more stars in the universe than there are grains of sand on all the shores of Earth's beaches. It's a really big universe out there, folks. Now, I want to overview three basic types of galaxies, the first of which is a spiral galaxy. Spiral galaxies will have arms extending from their centers. These galaxies will have large diameters, from 20,000 to 125,000 light years across. Our very own Milky Way galaxy is a spiral galaxy, and if you wanted to travel from one edge of the galaxy to the other, it would be about 100,000 light years of distance to travel. Now, there's another variation to the spiral galaxy, and that's what's known as a barred spiral galaxy. In a barred spiral galaxy, the band of stars extending outward from the central bulge merges with the spiral arms. In the bottom right portion of this slide, I've included a picture of a barred spiral galaxy. In this image, you can see the bar kind of stretching right through the central bulge of this galaxy, and I've indicated that here using a line. And then from that central bulge, you see two primary arms extending outward. One extends outward towards the top portion of this image, and the other extends outward towards the bottom portion of this image. Your typical spiral galaxy, which is shown in the image above, doesn't really have that barred central bulge. So it's very important to note the difference between these two types of spiral galaxies. The other two types of galaxies are elliptical galaxies and irregular galaxies. With elliptical galaxies, most are smaller than spiral galaxies, but they also are some of the largest galaxies that we see. So, put more simply, the size of elliptical galaxies can vary greatly. Now, the term we use to describe a small galaxy is a dwarf galaxy. And in this picture of Andromeda, you see two companion dwarf galaxies, both of which are elliptical galaxies. These little dwarf galaxies are kind of hanging out towards the outer edges of Andromeda, but it's important to note that galaxies can merge, and I'll talk about that phenomenon very shortly. The final type of galaxy that we'll consider is the irregular galaxy. Irregular galaxies will lack symmetry, and they make up about 25% of all galaxies that we observe. Irregular galaxies will contain mostly young stars. At one time, many of these galaxies were spiral or elliptical galaxies, but the gravitational effects of a neighbor galaxy distorted their shape. Now I'd like to shift our attention to galactic clusters. And a galactic cluster, put as simply as possible, is a group of galaxies. Some of these galactic clusters can contain thousands of galaxies. And what's truly awe-inspiring is looking at this picture shown on this slide. All of the points of light that stand out in this image are galaxies. Many of the galaxies you see are elliptical, although one galaxy that really stands out towards the bottom right portion of this image is a barred spiral galaxy. I would also like to overview the local group, which is our own group of galaxies. In fact, our local group consists of more than 40 galaxies, and over time that number of galaxies may increase because there may be undiscovered dwarf galaxies out there. And then one final consideration I'd like to overview is the supercluster, which is a huge swarm of galaxies. In fact, these may be the largest entities in the universe. Our final consideration in this vodcast are galactic collisions. As previously mentioned, one galaxy's gravity can disturb another galaxy, and it's very possible for a large galaxy to engulf a smaller dwarf satellite galaxy. In fact, our very own Milky Way has two dwarf satellite galaxies, and those dwarf galaxies are currently merging with our galaxy. Now, it's very important to note that the majority of a galaxy is empty space. So when galaxies merge, there will be surprisingly few collisions between stars or solar systems. In fact, two galaxies with similar size could pass through one another without merging. There may be gravitational interactions between the matter in those galaxies, but the number of cataclysmic head-on collisions will be lower than you'd probably think. It is important to note, though, that if two galaxies do run through one another, those gravitational disturbances could trigger the collapsing of nebula, and that could lead to an intense period of star formation in that galaxy. It's also interesting to note that in 2 to 4 billion years, there's a good chance that our Milky Way galaxy and the Andromeda galaxy will collide and merge. So, even despite the fact that we'll all be long dead, it'll be interesting to see the evolution of the Milky Way galaxy if this event occurs. Okay, that's the conclusion of this vodcast. In our final vodcast for Chapter 16, I will overview the fate of our universe. Perhaps more specifically, I will overview the possible fates of our universe.